Okay, this is problem number 2 on quiz 3 on the purple form of the quiz. So I want to estimate the instantaneous rate of change of this function, negative x squared plus 2x minus 1, at x equals 0. So first things first, remember instantaneous rate of change is the derivative, and well, we can find the derivative and actually calculate this, and I gave 1 point if we did that. However, I has to estimate, so we need to use an approximation technique here. So remember, the instantaneous rate of change, what's the limit as h approaches 0 of this guy? F of a plus h minus f of a over h. But if I'm only going to estimate it, well, I can just take this and just plug in a really, really small h, right? So I'm trying to approximate a limit as h approaches 0. Well, just pick an h really close to 0. We've done this before with other limits. In this case, it's just a special limit. It's the derivative, but I want to estimate it. So in this case, we're given, looking at x equals 0, so a is going to be 0, and h is going to be, let's say 0.0001. Okay. Now, plug that in, get f of 0 plus 0.0001 minus f of 0 over 0.0001. And you do this, and just be taking f of 0.0001. So over here we're going to get negative 0.0001, square it, plus 2 times 0.0001 minus 1 minus, well, we already found f of 0 up here. So if you look up here, problem number 1, well, I had f of 0 on the right over here, so I had this guy. Well, that's just negative 1. Right? So minus negative 1. Okay. All over 0.0001. So this is what you needed to do, and once you plug all this in, you're going to get, this is something like 1.999. It might have been another 9, I think. Well, that's going to be approximately 2. So I'm going to estimate this is probably 2. You could have left it as this as well. It's only an approximation, so close enough. There was also another formula that could have been used. This guy. I saw this in a couple quizzes. Right, so f of a plus h minus f of a minus h over 2h. Right? And this actually, I believe, once you plug this into your calculators, you end up with, well, a plus h and a minus h. You're just going to get 0 plus 0.0001. So you get this guy. Plus 2 minus 1. Subtract from it. You get negative run out of space, but plus 2 times negative 0.0001 minus 1, all divided by 2 times 0.0001. So if you plug this into your calculator very carefully, you'll end up actually, it'll round itself to 2. So I think this one up here is a little easier to plug in and get a number out. This one actually rounds a lot closer though. Either way will work. We're going to find that the instantaneous rate of change at x equals 0 is approximately 2.